today's webinar topic, as you all are aware, is AWS Lambda. So myself, Pratik Patel, I am working at Aspire Software Private Limited as a project manager come VP engineering. And I have been working with cloud technologies since last few years. If I talk about my experience, I have a good knowledge of Java, JavaScript, as well as cloud-based technologies. So let's move ahead. So yeah, this is uh, regarding our organization. So as you can see here, our organization, Aspire Software Private Limited, is working since 2010. And yeah, you can see my photo and our CEO and Ramesh, uh, who is leading ERP branch basically. So we started together, and then it's now 13 years. And as you see over here, we work for more than 200, 250 plus customers across the globe. And we work on a different technology stacks like Python and Odoo and Mon, Mean, Spring, even AIML. So this is the short introduction about your organization. If you want to know more about our organization, you can go through our website as well. Okay, so without wasting much time, let's jump on today's topic. So in this webinar, we are going to cover this particular topics. As you can see over here, we are going through the overview, what is Lambda and all those things, then how can we invoke it synchronously, and how it will be invoked asynchronously. We will try to understand what is event source mapping and destinations in Lambda, what are the execution rules, and how can we like log and monitor the Lambda functions, how AWS handles the concurrency and Lambda throttling, what are the layers, versions, and areas term in Lambda, and what will be the limitation we need to take care while we chose the Lambda as our compute resource. Okay, so these are the specific topics which we are going to cover in today's webinar. Okay, so uh, all are aware of cloud technologies. Anyone who is not aware of cloud technologies? So it is hard to get a response from everyone. So let me basically go through the basics of what is cloud and what is Lambda. So basically, cloud is not which we are able to see in a sky. Basically, it's a, a set of resources which are provided by some company, which helps IT, other service IT companies to get the compute and other resources. Like before cloud invention, we were setting up all the servers and everything in our company premise. And for that, we need to handle all security, then required compute resources like addition of new resources and upgradation of resources, and everything we need to handle by our own. Instead of that, now Amazon and Azure and all these companies are providing us all the resources and facility. So our job will be easy, and we just need to focus on our actual business logic and softwares which we need to develop on a client request or for our own products. So one of the major cloud provider is uh, Amazon, and in Amazon there are multiple services, and one of it is Lambda. Okay, so what is Lambda? So Lambda is a serverless compute. Basically, compute means we can say it's a kind of a virtual machine, right? and it will provide or help us to execute our business logic through any language like Node or Java or any. Okay, so I go back to Lambda. It's an event-driven, serverless compute platform and function as a service. Okay, so this second term, I have a high level explained you. Let me go back to, so before Lambda, what we were doing is, suppose we have a machine. Just okay. Suppose we have a machine. Okay, and we have deployed some web application in it. Now our machine is connected with internet, and from internet there are multiple users are trying to access our application. Okay, so what happens is, in normal computer or VMs, we need to keep this machine up and running 24/7. Okay, whether our user base is using our application or not, we need to keep this up and running 24/7, and that means there are lot of uh, dollars or price we need to pay to use this VM to AWS. Uh, Very famous AWS service is EC2, which provides this virtual machine services or compute. Now, how Lambda help us to save this money? Lambda is a function as service, as we read over here. So we can write a specific function, just like to create a contact or create address or update address. We can create any kind of routine or business logic in a Lambda, which will be a separate function kind of microservices. Okay, and that function will not use any of the resources until we are not going to hit that function. Okay, so what will happen? Lambda is there. Okay, but it will not charge us. When this user will try to hit or use that business routine, like this function is to add new customer in our application. Okay, so when this user will try to add new customer in our application, this lambda will hit. It will spawn a new behind the scene machine or a VM. It will uh, put this function into this virtual machine. It will execute that whole business logic and respond back to customer. And AWS will charge only for the seconds or milliseconds we use this particular Lambda, and depending on Lambda configuration, like how much memory we have configured for that Lambda. So it depends on that. So that means, depend on our business requirement and usability, we will not be charged for the resources where our user is not requesting or doing any kind of compute on our application basically. So that's why Lambda is a very popular. So and why serverless? Because everything will be managed by AWS behind the scene. So it is not like serverless means there are no servers. Yes, there are servers, and it will be automatically managed by AWS. It should not. So we don't need to provision those server. We don't need to take care about the scaling. Uh, We don't need to take care about cluster. We don't need to take care about any networking concept. Nothing. Everything will be managed by AWS, and that's why it is called as a serverless. So serverless is not means there is no servers. Yes, there are servers, but those are managed by cloud providers. Okay, so that's why it's a serverless compute platform. Now, event-driven and function as a service, we'll discuss these in depth in a later uh, screens basically. Okay, so high level we have discussed about why lambda. So it's a virtual function. Automatic scaling. Automatic scaling means depending on the concurrent multiple requests, AWS will automatically generate the Lambda instances. Suppose we have a 500 different users and they are trying to add new customer. Okay, and one function will handle only one request at a time. That means we will require a 500 different Lambda instances to handle that invert requests, and that will be managed by AWS automatically. So AWS will automatically generate the 500 different instances for that same Lambda function, and it will be managed by auto scaling basically. So that's why it's a automatic scaling, and it's handled by AWS. As I explained before, it's a on demand, and only we need to pay what we are using. Okay. AWS also provides a very handsome amount of free tier. Like if you see over here, it's a lot of Lambda free tier requests available, and it also provides this much of GB compute time free. So if anyone wants to just create a POC or like a initial stage of proof of concept kind of thing, they can use it and they don't need to pay anything to AWS basically. So it's a good for startups as well. Monitoring and observability. So Lambda is handled and managed by internally AWS, but they provide a lot of different service integrations like CloudWatch integration, CloudTrail integration. By using those services, we can easily monitor and check the insights of Lambda execution services or functions. We can easily troubleshoot it basically. Okay, we'll check these all things, and we will cover all these things in our webinar. It is built in fault tolerance. As I mentioned, it's a serverless. Everything will be done by AWS. We don't need to take care about any networking concept or any uh, virtual machine crash or any kind of thing. Everything will be done by AWS, and it is fault tolerant. So if our AWS server has been crashed, then also they will like mimic our Lambda functions to other node, and it will be available for us. Integrated security model. Yes, as I mentioned, they have implemented this out of the box, so we don't need to worry about all these things. And it supports many languages. So if any Python developer wants to use Lambda or Java developer wants to use Lambda, Node developer, uh, there are lot of famous programming languages Lambda currently supports. So anyone can use it with their choice language. Uh, yeah, and as we discuss high level, this is the main reason. It's a very cheap. Is if you see over here, uh, 20 cent per million. So per request, we just need to pay this much of amount. This much of GB seconds are free. So it's a very cheap, and everyone can afford it, and that's why it's a very popular basically. Okay. So yeah, before we move forward, let's jump onto small practical kind of thing, so it will be easy for you guys to understand. So uh, if you guys are familiar with the AWS, this is the console home screen where we can find all the services provided by AWS. We can just search over here and it will be available. So few services are here. We are currently talking about Lambda, so let's open that service. Okay. So as we saw before, is a function as a service. Okay, so there are infrastructure as a service. There are, I'm sure you must be aware of its SaaS. So it's a function as a service. So what we need to do over here in dashboard, we can see few functions. Similarly, we can create our own function over here. Okay. When we create this function, there will be a few different options. We can create it from scratch. We can use existing blueprints available. They provide few blueprint, and also we can configure our own custom container image. Suppose VB is not supported over here, and we want to use VB, then we can create our own Docker container which follows uh, uh, Lambda interfaces. We can use that uh, uh, language also. So, but we are not going through all these things. Let's go through this scratch. So here we need to provide some unique name of that function. So let's see my lambda. Okay, lambda demo function. Okay, over here there is an option to select multiple languages. So as you can see, we can use .NET, Java, Python, Node.js, right? So we are going to use Node.js for this webinar. Here is the architecture. So Node.js with which OS we need to execute. We want to execute this function basically. There is a permission. So execution roles. We will discuss about it later, little bit later in next couple of slides. But we are providing basic permission over here. These are the few things which are optional to use if we want to use like functional URL or code signing. Currently, we don't need to. Let's create a function. Okay, so once a function uh, will be created, you can see this kind of screen. You can also see it in a Lambda dashboard actually. Once you go through the Lambda dashboard, there was a 4 function, now it is a 5 function. And this was the function which we created recently. This is our function name, and this is the handler function. So whenever we execute this function, it will generate a invoke event, and invoke event uh, will be handled via this handler variable. Okay, so over here, let's just try to print something. All is my first lambda. Okay. Now, this is just a sample Node.js handler code, but you can write anything you want. You can even import third-party like packages also. If you are uh, working with databases, you can import database packages like SQLize or anything you want. Uh, we'll check that also later how you can import it. But currently there is no dependency, third-party dependency required for our code. So this function is done. Now, if we want to test it, how can we do that? We just need to deploy that first. So it will be deployed somewhere in AWS. And that's why it's a serverless. We don't need to handle everything. And once we deploy, we can test it from here. So if you see here, it accept event object. So while testing, AWS will ask us to configure event objects, which is a sample event object for testing. So let's give some good name. My first test event. Okay, it will use this as a request body. Let's save it, and now we can test this lambdas. If you see over here, this returns this hello from lambda, and if you see in a log, here is in my log, hi all, it's my first lambda. Okay, so this is a simple function which we can execute, and we can perform any kind of business logic. As for example, we can add customer in our application or anything we can do. Now, uh, let's go back to slide. So this is a synchronous invocation. Now, we have tested independently from the AWS, but how can we integrate it with our front-end application? Like if we have selected to write our application in React and Node, uh, React will be separately written by some team, and they will try to execute our provided APIs which are in Node.js. Let's assume this is a one API we have developed, and this API our front-end team needs to execute. So they can't come here and test here and then integrate it with their front-end application, right? So we have to provide them some kind of REST API. Okay, so yes, this is not part of our this Lambda, but I'm going to use uh, API gateway to just showcase you guys how can you create a REST API and integrate it with Lambda, so you guys can share it with anyone in your team, and they can use your services as per our configuration. Okay, so I'm creating one API. It's let's go with the REST API. Let's do some. Okay. There are multiple options. Let's now go through it. Okay. So here I have created API gateway. Now, just like a Node, Node and Express application, we are creating a we used to create a routes. We can create route over here also. So or add customer and customer. Okay. So let's create first resource path. Okay. Okay. So slash is already there, so we just need to use resource path. So now we have one resource, and we need to integrate our Lambda function here. How can we do that? So first of all, we need to create a method. Here there are multiple options. Okay. And which type of HTTP method we want to integrate, we can configure over here. So we want get HTTP method. Then there are multiple services or our third-party HTTP request we can configure from here. But for now, we are interested in Lambda function. So this is the region. Depending on which region we we created our Lambda, we need to choose that region. So over here, we have created in Virginia region. So it should be somewhere here. This is, if you see over here, my Lambda demo function, which we recently, just before few minutes, we have created. Okay. Rest, I think it's in depth, so let's keep that. Let's integrate this API gateway with our created Lambda. Yes, it's been integrated successfully. Now, similarly, we deploy Lambda, we need to deploy our API gateway where we can define our stage like QA, production. So it's our QA stage. Let's name it QA stage. Once we deploy it, it will be available in our stages, and we can see from here. So this is our invoke URL. Okay. We can configure this also, whatever domain we want, but for testing, it is fine. Now, let's try send API. Yes. See, so we have one REST API ready. So using this URL, we can hit our API gateway. That API gateway hits this particular function, and that function returns hello from Lambda here with the status code. Okay. So this is the example of synchronous invocation. Okay. Everyone must be aware what is synchronous invocation and what is asynchronous invocation. Synchronous invocation means if we send some request, HTTP request to server, server will process immediately and then respond back immediately on the same request response, whatever the like requested resource from the user. So it will be responded in that same request response. So that's a synchronous invocation. So we just saw same example, like we can initiate with the CLI or console CDK, or we can do via client. So in this case, our client is a Postman. So our client initiated request to the API gateway, and API gateway generated a proxy request to Lambda. Lambda responded to API gateway, and we get back response to client. So this client can be a React application. This client can be another application. This client can be a browser. Any HTTP supported client we can use to integrate this synchronous invocation HTTP request. Now, a few things which we need to take care, or like one is a error handling. So error handling must be handled on the client side. So suppose there is some issue on the server end, and we are not able to reach to our server, like our Lambda. Server cannot handle it on the server side. So when we get a 404, or when we get some error on the client side, we have to handle via our client side application logic, and we need to handle via retries and exponential backoff methodology, and we need to keep on continue try and hit the server whether the server is back or not, something like that. So error handling must be done at the client side. If we are following synchronous invocation, server will not handle it automatically. Okay, so that's the main thing we need to take care. Second is asynchronous invocation. So as I explained before, asynchronous synchronous invocation means initiate the request and get the response back immediately. In this case, we are going to initiate the request to server. Server will take the request, keep it in a queue, immediately client will get back the response that server has taken our event or request, and server will handle it one by one. And once it's been handled, we will get an update on the server end. So our HTTP one request established, and then connection will be destroyed, and then server independently process our request, as we can see in this diagram. So S3 bucket, suppose we want something like S3 bucket. If you are not aware, S3 bucket is a service from the AWS where we can store our files, uh, uh, and like any kind of files we can store over there basically. So it's a storage service. So something like that, if third-party service push some file to our S3 bucket, and we want to convert that, suppose that file is image file, and we want to convert it in a different uh, types basically. So that file came from the another application. It is in some PNG a PNG type of a file we get from the third-party application, and we want it in a multiple types like JPG or thumbnail. We need to create a thumbnail. So what we can do is we can create a events on a file, add, update, delete events. It will generate an event. It will send it to the Lambda. Lambda internally manage the event queue. We don't need to handle this event queue. It will handle internally. It may be a SQS, but it handles internally. And later when Lambda pick up that message, it will process, and then it will generate a response as per the Lambda uh, business logic. Now here, if Lambda fail to process it, depending on our configuration, Lambda will retry uh, maybe twice or thrice, depending on our configuration. We will see where to configure it, and try again to process same message. If not, if we configured PLQ, our process, our like a failed message will goes to any kind of queue, and later we can check why it is failed. So why I'm telling all these things, because we need to understand that in asynchronous invocation, retries and all other related exponential backoff and all the things, error handling will be done at the server end from Lambda itself, depending on our configuration. So client don't need to handle it. Okay. And if it will retry multiple times, then definitely we will be able to see the multiple times logs for the same functions execution. Okay, we'll check that also. So let's try now asynchronous invocation. So I have created one. Okay. So over here, what I did is I have created one function similarly what we did before, and I have just print event object over here. Okay, so as per this slide, S3 bucket will send an event object, and that event object will be print as a part of our event processing. We can do anything over here, but just for a understanding purpose, I have just printed event. And if this uh, Lambda function is unable to process our message, it will send this message to configure DLP. Now, how can we do that? Let's check that. So once you create a Lambda, there will be a configuration tab where we can do all this configuration. So first is a general configuration. So over here, we can configure our Lambda resources. So how much memory our Lambda will use maximum. So currently we have configured 128 MB. Hard disk we have configured 512, we don't need to configure CPU. It is based on memory. How much memory you configured, based on that number, AWS will automatically configure the CPU. That we'll discuss soon. This is the timeout. So it will wait for 3 seconds only. If Lambda will be not done with the execution within a 3 second, it will give a timeout error. And maximum we can configure 15 minutes only, not more than that. So if we have a use case where we want to execute a long running process more than 15 minutes, Lambda is a not good choice for that use case, definitely. Execution role, we'll check that, but it is a permission to execute few resources on AWS. Second configuration is a trigger. Okay, so here, as I mentioned, S3 bucket will execute this Lambda function asynchronously. And for that, we have to configure these triggers. How can we do that? So let me add one more trigger. So over here, let's select S3 bucket. This is the bucket which I have created. This is the event types. So which event type, on which event type we want to call Lambda. So let's say put, HTTP put. So some object or some file will be uh, uh, use put HTTP request to update the file. It will generate this particular Lambda. We are saying that. So that's how we can configure. If we check event, I have created already. So this is the bucket. A second. And this is the detail of event. Now, what will happen if I put something in this file? Let me upload first. Let me upload this file to S3 bucket. Okay. As soon as I'll upload, it will execute this particular function, and we can check the execution logs here. So it's 29 and it's in local time zone. I think we received this event from, see, this is the event we received. So this was the bucket name and this was the file. If you observe, this was the file I have uploaded. So this log came from our this code and this console log. That means when we uploaded, S3 bucket sent an event to Lambda and Lambda asynchronously executed this. So S3 bucket don't or any other application don't need to wait until this Lambda process has been done. It can independently execute further process. So that's why it required a asynchronous invocation, right? So
Hello, hello everyone. Is there any question till yet? Anyone has?
yeah, definitely you can shoot. Even I'll give you a 5 minute of time after completion of whole presentation. So you can ask right away or you can ask later also.
Sure, no problem, sir. Please go ahead.
Okay.
Sir, you are muted.
Oh, sorry, sorry, everyone. So what I was trying to say is this is the asynchronous invocation configuration as we were discussing. So from configuration, uh, there is a asynchronous invocation tab, and from there you can configure your retry attempt and date later SQS. So if your function will not be successfully executed, then AWS will retry this function multiple time depending on this configuration. If you have configured 3 or 4 attempts, first time it will execute. Suppose it will execute after 1 minute again. Then second time it will execute after 2 minutes, and third time it will execute after 4 minutes. So that is called exponential backoff strategy. And 3 or 4 times, depending on this configuration, it will try to execute again and again. If still it's not get success, then that message goes to this date letter queue. So later on, developer team can check the message, what was the problem and why it was not processed, and they can fix it and then again send it for processing. So there will be no chance of any data loss basically, or any event processing. So everyone uh, will be make sure, application users will be make sure that their request will be processed 99.9%, right? Okay, so let's move forward. So event source mapping. So it is this event source mapping and this destination, both concepts are related to synchronous and asynchronous. So we'll go through it quickly. So in event source mapping, as we saw before, this is the function, and this is the trigger, and this is the destination. So whatever the trigger we configure, it will become a event source mapping. Why? Because this is the service, or this is the resource which is going to trigger this function basically, and it will send the event to our Lambda, and that's why it calls event source mapping. So from here we can configure any service. So suppose we can do something like SNS. So some message came to SNS service. We want to execute this Lambda. Suppose we got a OTP, okay? And OTP came to AWS SNS service. Now after OTP, we want to do some background processing. So on the SNS event, it will automatically trigger our Lambda, and Lambda will process whatever we want. So that's why it's called a event uh, source mapping. Whenever we do any event source mapping, that Lambda invocation will be done synchronously. Okay. And in event source mapping, majorly we can configure um, streams like Kinesis and DynamoDB. I'm not sure you guys are aware of it or not. But DynamoDB is a database, key value database, and Kinesis is for live data streaming or maybe processing. So we can use with that, we can use with SQS, we can use with SQS FIFO also, and we will get event object as well as context object. So event object we already checked. Whatever the service provided in their request, we can get it as an image object, and we can process using that event object. Suppose I want to process employee salary. So I need to send employee ID. So I need to send it into event object. And by getting employee ID in event object, just like how we get file name, uploaded file name, we can process further whatever we require. And context object is about that Lambda environment. So suppose if we want to check how much memory my Lambda is using, or what's the Lambda function or ARN name, we can check it via context object. Okay, so I have created one function to check it. So, okay, text object, I think I require the all possible. Hmm. Let me go through it quickly. So these are the things which we can uh, print or use in our Lambda function, and it will provide the information about that Lambda context itself. That means if we want information regarding the execution environment, we need to use context object. And if we want to get a data from the third party event sender, we need to send it in a event, and we can get it from the event object. I hope that is clear. Now let me give you a quick. Okay. So suppose memory limiting DB. Let's explain this. Okay. Let's deploy first. Without deploying, it won't update the changes, and then let's test it. So see over here, it gives this 128. So it's our memory configured for the Lambda function. And if we go through the event object, print event. So whatever has been passed from the third party invoker, we can get it in a event object. Right? So here this came by because our event object is a test. So instead of this, if we can do name, consider you are sending this request payload. Process from Lambda. Saved it. Then test again. So you get that request body and all the context related detail. Okay. So this is the event object and context object. Okay. Is it clear, everyone? Any confusion till now? We checked Lambda function, we checked async, how we can call asynchronously, what is asynchronous call, what are the differences between both. Uh, then we check event object, we check context object, how can we uh, expose our function via REST API that we have checked. So till now, any confusion, any issues?
Please feel free to ask any questions you had in your mind.
Okay, I take it as a no, but prefer to ask. Destinations means uh, we can configure the destination in the uh, when we do the asynchronous invocation, or when we do the event source mapping, and we can configure that on failure or on success of message, what should be done after that. Suppose I processed something like I got one event from the S3 bucket where I have created a thumbnail of that image using this Lambda function. Now I have added that thumbnail to some another bucket, but then after I need to process further. Okay, or I want to handle the error. How can we do that? We can create a pipeline via this destination. So once our function will be done with, if it is a asynchronously invoked and our function's result is failure or success, what we want to do? We want to send that message to SQS. We want to send a notification to SNS. We want to execute another Lambda function which will move our thumbnail to our database or somewhere else, basically. So that's how we can configure our further actions as a part of whole business process uh, execution, basically. So that's the destination. And good thing is we can handle both successful and failed events. Execution role. So this will require a little bit depth knowledge of IAM permissions and resource related permissions of AWS. But I'll try to give you the high level idea what it is. So we are not going to discuss it in depth, but AWS provides a few policies and roles, and it will require to associate with specific services to execute. Suppose I want to send this Lambda logs to CloudWatch service. So both services are different. So if I have a permission to send or put my Lambda compute logs to CloudWatch service, then and only then we can send our logs to CloudWatch. Otherwise, it will deny. So that's a security purpose. So by default, basic Lambda execution role AWS provided, and when we have created this function, you saw here create new basic Lambda permission. Okay, so when we select this behind the scene, it will associate that Lambda will be associated with this role, and then Lambda it will be capable to upload our logs into CloudWatch. Similarly, if we want to work with other services, we need to use that role. Otherwise, we can't use that service, or we may not put our logs there. It depends what service and how we want to use it. So it's a very depth concept, but consider that we need to configure proper roles and permissions and assign it to Lambda to use other services. Okay, logging and monitoring. So partially we have already checked it. Let's go through it again quickly. So over here in monitor, there is a CloudWatch log, there is a X-ray trace, and there is a matrices. Okay, so matrices provides all these graphs basically. So invocations means how many time and when our function has been invoked. So one invocation is here, one invocation is here. So we can check how many concurrent or at which time it's been invoked basically. How much time it's like up and running. So when it invokes, it take around 39 milliseconds to finish our job basically. And is there any error? So we can check from here what is the success ratio and error count. So suppose we invoke for 2 times, and first we got a failure and second time we got a success. Over here you will see that success rate is 50% and error count is 1. Okay, that's how you will see over here. Total means it's a little bit uh, detailed concept, but high level, if I give you the insights, Lambda concurrently provides thousand invocation by default. If your users try to exceed that limitation, suppose there are 10,000 users and trying to invoke same function at the same time, you will get the total error, and you will not be able to execute. Uh, Basically, your application will not be able to execute more than 1,000 requests at the same time. So either you need to ask AWS to update your concurrency, or you can see your throttle error over here. So you can observe and you can like act accordingly. So total concurrent executions, one, right? Recursive invocation dropped, how many? In async event, as I mentioned, it's initially go to the queue and then one by one it will be processed. So this event, uh, uh, it's been in a queue from how long basically? It's in a queue from last 5 minutes or 6 minutes. So it will show you the event age. Then how many async events you received, how many you dropped, any failures or any iterator age. So there are a lot of this will require a lot of depth knowledge. So we'll not go to it, but high level you can observe everything from here, and we can also check the logs. So here are the different function logs. We are checking for this demo function. Currently, if you see, there are two streams. Let me delete it. So you would get confused. There are no streams. Now, if I execute that function again, you will see new stream over here. When I open, you will see what was the execution log. Okay, so it will be very easy to log in a production as well, and you can also uh, like easily change your configuration accordingly or matrices and logs. Okay. Mm, yes, so concurrency, as we discussed high level, 10,000 concurrent executions will be supported. And if you want more, you need to raise a request. If your concurrent execution limit is done, in a synchronous Lambda call, you will get a throttle error with 429 response. And in asynchronous, uh, we can't do it logically. If you think we are just sending an event and we get a response back immediately. So Lambda can't give us back a throttle error as a 429, because at that point in time, even Lambda service may not aware that when we try to process this message, it will be throttled or not. So that's why, depending on our configuration, it will retry automatically, and if not able to process, it will goes to TLQ, and developers can further check, debug, troubleshoot, and process the message again. Sorry, oops. Cold start. So a cold start is currently maybe we may not observe, but why it happens. So when we try to execute some function first time or after a long time, behind the scene, as I explained initially, what I mentioned is user will request to Lambda function via API gateway or something, or a React application. So on a first request, it will generate a VM behind the scene. It will deploy our code in that VM, process it, and then give a response back. If immediately user will send another request, it will use the same context. This is the context, right? So it will use the same context. So this whole uh, deployment and infrastructure related timing uh, uh, will be not there, and that's why it will be very quick, basically. Okay, so fast request when we serve, it will be little bit slow, and then you will get a fast response. So That's the thing. And two more parameters we need to configure when we consider a concurrency related stuff: reserved concurrency and provisioned concurrency. Now, what is reserved concurrency? So suppose uh, there are total 1,000 concurrent execution will be provided by AWS, and it is shared among all the Lambda function in your account. It is not for any one function, okay? But you are one of the functions. Suppose you have created a function for e-commerce application. One gives you a product list, second gives you a product detail, third is providing you a payment solution. Okay, so payment solution and other functions usage will be less than a product list API, right? Or product list uh, uh, Lambda function basically. So what we can do is we can reserve more concurrency compared to other functions. Like we can configure 800 or 900 concurrent executions for just for a product listing, and others will be shared among the rest of the Lambda functions. But the problem is if that function is not using that much of selected concurrency. Suppose I have configured for 800 for a product listing, but now product listing API concurrently use only 100 executions. Then my 700 executions will be wasted. And if another application is trying to execute more, then also it won't uh, uh, be executed and will give a throttle. So it's bit confusing. If you guys have any question, I can explain it again. So consider this way. There are two functions, okay? One we have configured with 900 and second we have configured with 100. Now this 900 uh, uh, configured Lambda function is utilized only 100 at a time as of now. So 800 still pending. And this second function wants to execute 101. Still, although we have 800 free invocation execution from this Lambda, second function can't execute that and it will be throttled because we have already reserved for the another function. So when we choose this parameter, we have to choose it wisely depending on our requirement. Okay. And second is for the not reserved, but how much uh, already create the context. So in a cold start, we learned that on a first request, it will generate the context and it will take a time, little bit time. But user don't want to uh, do that. On the first request itself, user wants the response in a millisecond. So what they can do, they can configure a provision context. So suppose if user configured or developer configured provision context as a 10, then 10 instances of Lambda will be up and running behind the scene. And whenever first request come, there will be a no delay to respond back. Okay, but that involve money. Okay, so we are not going to do practical for that, but it's a theoretical concept. Okay, player versions and areas. Okay, so suppose you want to use any third-party dependency in your Lambda. How you can gonna do that? You can either upload that third-party dependency over here uh, uh, besides the besides your code source, or you can create a layers. Okay, so currently I have created one. this. Sorry, this one. Definitely not this one. Yes. So what I did is, well, I am creating one Node.js project. Okay. I am going to add a moment library, which we require in our project. Okay. Now, what we need to do is we need to follow some hmm, we need to follow some predefined rule. First is a Node.js folder. Then we need to put our node modules in it. Okay. Just like we did over here. And there will be a moment dependency. Now we need to zip compress this, and we can create now layer. There is a layers. Moment. Load a zip. Command. Second. I think I have created. I created. So we need to create from the Node.js. Okay. Then it dependency. And then upload it. Now it will be for our Node 20. So it will create a layer. And now layer is available to use in our Lambda. How we can use. So there are no layers over here. And we can add layer from here. Already available layers will be listed over here. These are the predefined layer. We need a custom layer. So moment and this version. Okay. So one layer is there. Now we can import and use it in our code. We go through the moment function. We can use one of it just to check it is working or not. Let's deploy. Let's test, and it shows 12 years. So we have used dependency from the layer. Why we need to use this layer can be shared among multiple lambdas. Second, uh, there is a limitations. We will check in a last slide. So 50 MB of zip code and unzipped version code should be not more than 250 MB. So if we add every dependencies in code, we may reach to limit, and there will be a problem. So that's why we can use layers for the dependencies or custom solutions basically. So that's layer versions. Yes, here there are multiple versions we can create, and we can create an alias. So we can publish any new version after code change, and we can go back to any version via using alias. So currently my alias is uh, pointing to version 1, but I want to test now version 2 code. I can just change it and I can test it. So it is like the uh, switch of branch basically. So that's why we use versions and alias. And these are the limitations. So we just need to keep in mind before we select the Lambda. So memory allocations for the compute is minimum 120 MB and maximum 10 GB. Maximum 15 minutes of process we can do. Maximum 5 layers we can use, but uh, uh, we can club multiple dependencies into one layer and use it. One more thing, for 250 MB of zipped or unzipped code, layers will be considered. So we need to take care about that also. Your code size should not exceed more than this, basically. And this is the request and response payload limitations, and it provides the hard disk as well. So if you want to download anything while processing and do some uh, any kind of um, maybe further processing on that file, you can do it by downloading in tab. Maximum you will get a 10 GB of storage. So these are the some limitations before you decide to use Lambda. You need to go through it. There are more, but these are the top one which you must be aware of. Okay. Yeah, I think that is it for this session. We just scratched the surface of Lambda. There are a lot of things in it. If you would like to know more, definitely you guys can uh, message us or comment us on a LinkedIn. And as I promised, I'll give you a few minutes. If you guys have any question, please shoot.
Please raise questions on chat if you have any. I think no one has questions, sir. Thank you so much, sir, for this insightful webinar and insightful information about AWS Lambda. And we will looking forward for more information and in depth. We will definitely go in depth in the next session. Thank you so much,
Sure.
everyone.
I would
Thank you,
like
sir.
to definitely, I would like to share if everyone wants to. So if everyone wants, just comment in our LinkedIn post that you want a second session or any other session, or if you have any question, just
Sure,
message
sir.
us.
You can contact us on our LinkedIn page as well, and you can contact us directly via message. Thank you so much, everyone, for joining this session.
Thank you. Thanks, everyone.
Thank you, sir.